due to time constraints and everything else, the idea is actually to have a DLL with stub functions. You know the C API because it's documented. So you can create a file that basically exports all those functions and just says return 0. Because all you need is the name rimos and your DLL linked to. And then you link this, or you create this by hand if you're really bored. And then make an ARM DLL with the embedded Visual Studio from Microsoft, which is for Windows CE, but creates ARM code DLLs. And then all you basically should need to do is create a description file and load the DLL onto the device. Now, we've heard that supposedly all binary modules are checked, and the signature on the DLL is as well. But as long as you don't try it out, nobody knows. So we had this talk, I think, 3 years ago about mobile phones. And of course, if you played with something like this before, you start just throwing everything that you found on the old device on the next one. So I tried all the issues with Siemens phones on the Blackberries, and turns out the JUT description file thingy actually kills the browser on the Blackberry as well. The responsible code is Java, and latest news is it's probably not a buffer overflow, but something is really, really wrong there. Interestingly enough, you could switch tasks so the browser would go in background, but you could not kill the browser. There was no way to kill the browser. Hard reset really didn't work either, which is interesting because hard reset should actually, power cycle your CPU or something, which it didn't. So you actually have to take out all the batteries and everything else, and then wait a minute, and then boot the device again. And it's fixed, by the way. Things to try. We've seen the pictures. I would be really interested in finding the JTAG connectors. For those of you who don't know, JTAG is actually a serial protocol for debugging on embedded devices. So it should be 4 connection points. Nobody played Bluetooth on the Blackberries so far. The only thing we have seen is turning Bluetooth repeatedly on and off crashes the device. This is actually, someone showed this here at the Congress to me. It was just great. The JVM is, invented by RIM and rewritten by RIM, so there is a high potential for bugs. Virtual machines are not easy to code correctly. Reversing images is always a good idea. Figure out checksums and everything that's, loading. And actually, Mark came up with the idea that loader.exe, the code should actually be able to read from the device as well, not just write to the device. Turns out he's right. The question is, can one actually use the code from the loader and make the loader read memory areas? It looks like that. So the interesting part about the whole BlackBerry story is the devices and everything is what you see. That's what you have in your hand. The way more interesting from a attack perspective, what you get, is this. It's the BlackBerry Enterprise Server. Most people actually don't know it exists. The BlackBerry Enterprise Server is basically a box that at one point in time someone was bringing into the company, and the security administrator goes to the box and says, "What is it?" And I say, "It's a BAS." And he says, "What does it?" "Well, it connects to RIM straight out of the net." "Okay, so we put it in the outer DMZ." "Oh no, it needs to sit right next to your internal mail server." "No." And then the CEO comes and says, "Well, I want my BlackBerry to work." Yes. This is the BlackBerry Enterprise Server. Everyone hates it. So let's look at what this beast is. The later versions actually, due to security concerns, contain a router. Big name, little software. It's basically a TCP proxy. It talks TCP proxy and proxies SRP protocol from the inside to the outside, and runs on Windows. And we have here the big BlackBerry Enterprise Server with a dispatcher, then mobile data something, a alert service, a attachment service, and a policy service, and a lot more files. It's a pretty big piece of software. Here you have a connector sitting on either your nodes, exchange, or group-wise mail system and talking directly to your BlackBerry server. This is why they need to sit next to each other. And then you have a Microsoft SQL database that contains like all the interesting stuff. And yeah, we're going to detail that. So here's how much permissions this beast needs. So you get 3 accounts. You can easily combine them into one, is what the administrator guide says. It's obvious why. They all need lots of permissions, so it doesn't really matter. You need the permission to log on locally and log on as a service, which is cool. You need the permission to be a local system administrator. You need read-only administrative permissions on the Exchange and full administrative permissions on the Exchange Mail Store. So that's a pretty powerful position, and therefore it's really interesting to look if you can abuse this position. The SQL database is actually installed by default with user authentication. It's running on Windows like everything in the enterprise server. I don't really get why they don't use internal authentication, because that makes a lot more sense, because you're running on a Windows account anyway, so you can use the built-in, a lot more secure mechanism. But they actually use user authentication, and yeah. No password. So it's basically just the user without the authentication part. We have tables for the individual messages and mails. They're just put into tables. But they also store all the keys in there. So if you have permission to connect to the SQL database because it sits right in the middle of your network, and you know how to enter no password, then you connect to your SQL server and basically do a table dump. And what you get is all the keys. You get the authentication key, you get the device keys, like the current, the last one, and the one that's supposed to go onto the device right now, which you, of course, can use to decrypt the traffic. And yeah, it's all in there. So when you see, this is the mysterious SRP authentication key that most people think is a software registration key thingy. So this is how it's shipped. This is how you need to transform it. You just take out the dashes. And then the entire algorithm to make it a usable key is you basically just left shift it. They only use 4 bits. It's called a 8 to 5-bit translation mechanism that comes up with 20 bits, with 20 bytes out of 40. Okay, so if you transfer something from 8 to 5 bits and then get half of the data back, it's probably more like 8 to 4 bits, which it actually is. But the code says it's 5 bits. And then they have a mapping table that you easily find in a binary. Yeah. The beauty of updates. Like all the security people tell you, keep updating your stuff. Same with BlackBerry servers. You get service packs, you get hotfixes. The release notes tend to be extremely entertaining. Things like, I created an appointment between me and someone else, and then a third person got a pop-up, or something like this. So you find extremely funny stuff in there. Hackers should actually update their BES as well. There are 2 reasons. First of all, news, there is something like bindiff, so you can take the update and see what's changed. And when the release note said, oh, we had this problem with the server crashing when someone had read a really long subject in the email, then you look at the update, look what's changed, and there's this condition, if subject longer than something, something, then drop email. And of course, the version before didn't have this condition, and here goes your exploit. The other cool thing is for reverse engineering, it's large binaries in C++. It's really not easy to reverse engineer, but you get free debug symbol files with the patches. So they ship the entire debug symbols with it, which is actually about 5 times as much as code they ship. Well, it's C++. And you actually get them in the updates, which means now you're not talking sub 4080 FE, but you're talking like SRP protocol decode. Really good. Code style and quality. Interesting because we're looking for failures of quality assurance or vulnerabilities. It's massive C++ code. It's by-the-book pattern implementation. So someone actually, took an entire university and hired them as coders. But it was a good university. They have really large classes, and they tend to write extremely large functions. It's mostly STL using code, so you don't find a lot of string copy and stuff in there. And it's fairly hard to reverse engineer until the first service pack because of the PDBs. It's surprisingly good. STL actually helps a lot. So when people actually have something like a real string class, they stop doing string copy because it's less convenient. They have a very conservative coding. So I was like checking the receive functions, and like the upper layer does a select, oh, there's a byte, calls a function, does a select, oh, there's a byte, calls a function, does it select, oh, there's a byte, let's receive it. So they really check often, but generally using signed integers, and the SRP issue that you've already seen is a typical signed integer issue. Interesting libraries they use. They actually use quite a lot of code from other people. So they use for Microsoft Office, they use the iStream classes, nothing better to do than that. For HTML rendering, they use the Microsoft thing, and they install MS XML SDK, and actually nobody knows why. It's installed, and you get a documentation on a desktop, but you can easily uninstall it, and it doesn't change anything. This company, Horizon, they're now RIM. So I think they got bought a while ago. And so this is now all RIM, but it's their former product. It's a central parsing engine for the attachments. And then they implemented PDF parsing and Corel WordPerfect parsing for the attachments. Interesting libraries, open source. Now we're getting into something really funny, because the zlib is not really recent, and it's of course used to unzip files. Known bugs in a library that someone uses in a big product is always a good news. Graphics Magic is a spin-off from Image Magic, is a huge pile of code. It's for image parsing and writing and everything else what you know from Image Magic. Graphics Magic actually is a lot bigger than that. So it's, I think the latest version is like 35, 40 megabytes of plain C code. And it's fully linked, including the debug code, so you can match 101. The same for the zlib, for example. You can match 101 what code they took. So the unzip code is actually unzip.c from the contrib directory of zlib. And you can sit with the binary and the source code and match it one-to-one. So with debug symbols, it's really easy to do the same for Graphics Magic. And this is what Graphics Magic supports. OK, how good are the chances that you can parse all those file formats correctly? Yeah, about that. So they actually don't openly support them. Openly support is something like PNG and TIFF. And what happens is you have this Arizon pre-parsing engine. It looks into the file, and it sees like GIF98A. And says, oh, cool, GIF file. And then puts it into this monster beast open source library and says, make a plain image out of it so I can send it back to the crackberries. And this thing gets it and then tries to figure out the format itself. Now the question is, can you make a combination where the identification says it's PNG, all you want is passed to the library, and then build an XBM file and exploit an issue in the XBM code. The changelogs of Graphics Magic, of course, when you identify a big open source library being used in the product you're just looking at, next thing you do is download everything, every version they ever had. and see where they came from, where they're going. The changelog is really interesting. It talks about like security patches.